So at the top of this, we have angle addition and segment addition. There's lots of properties we're going to add in today. These are not new properties. We've already done this. So I'm going to give you an example of each. So angle addition, maybe we have a diagram that looks, here's an angle. I want to make sure we label it the same. So call this angle ABC. And then put in the middle, break it apart, and put point D there. And I'm also going to call this angle 1 and that angle 2, so that there's a couple different ways we could maybe use this in our proof. So one way that we could write out what's happening here is we can say that the measure of angle ABD, which is really angle 1 there, plus the measure of angle DBC is equal to the measure of our full angle ABC. Okay, that the part plus the part equals the whole. That's from our last unit, or not even, it was the first half of unit 2. Or if, say, my proof is using 1 and 2 instead of the points around my angle, then I could also have said angle 1 plus the measure of angle 2 equals our angle ABC. So two different ways, because there's two different ways to identify each of those parts of the angle, but I could write that out. Or I could have, give you a moment to get it down.
Well, my back hurts. If I go to the coffee, I will even try to. My dad was in the I don't know. It was really hard to wake up today, which is weird.
Because it's like a Monday.
Well, I didn't have to wake up today.
What?
There wasn't really any sleep last night.
I haven't been sleeping with
So now I have a segment AC,
No sleep.
and maybe between A and C somewhere, I have a point B. Well, if I'm given a diagram like this, then I could also write an equation like AB plus BC equals AC, segment addition, that a part plus a part equals a whole. So these properties, angle addition and segment addition, you'll see when we do our first proof here in a moment. But these aren't things that are, they're not going to be given to us to use angle or segment addition. These are what I call look-fors. So if I'm given a diagram where one of these two things are happening, maybe I need to use an equation like this in my proof. So that's a property, two properties that we've already seen before. We also have substitution property. This is one we haven't used yet this year, but you did use in algebra class. If I knew like x equals 5 and I have the expression 3x plus 4, then I know that I can substitute in for that variable and simplify. Okay, it's just substitution. Now, that's an algebra class. In our first proof, and I think the first two proofs, we'll see substitution in a geometry proof, which feels very different, but I'm not going to put it up there. I'm just going to, we'll put a little star and show it in our example down below. Okay, so now I need you 100% with me while we do these proofs. So here we have our first geometry proof, not an algebra proof. I feel like this is dark. So when I approach a proof, there's a few things I want to do. So first, I want to go through the givens. So it gives me, I have segment RT and segment PQ intersect at S, such that, and I'm going to mark what it tells me here. RS is equal to PS. RS is equal to PS. So the way I mark equal lengths is with tick marks, okay? And then ST is equal to SQ. So ST and SQ are the same length. Cameron, put that away. Okay, so first I mark my givens. Now I'm going to write down my givens because I have to include them in my proof. So I have statements and reasons. And I'm going to write RS is equal to PS. That's given. And ST is equal to SQ. That was also given. Okay, so the first thing I do is I mark all the givens on my diagram and I write the givens into my proof. Now, before I move on, I can't just like willy-nilly start writing random things down and hope I get to where I need to get to. I need to focus in on what it's asking me to prove. So what it's asking me to prove is that if this is true, that this segment, full segment RT, is equal to this full segment PQ. That's what it wants me to prove somehow. Based on how we marked it, do you think that that's true?
Yeah.
Yeah.
Yeah, because RT has this pink single tick mark and then the blue tick mark, so this plus this, and this is the same parts broken down, it's just on a different segment. Okay, so I do think that they're equal, but we need to not, we can't just say that. We can't just give the diagram and be like, look, they're broken into the same amount, so they're equal. We need to build a proof here. Okay, so I have my givens. I know what I'm trying to prove. I have nothing else. So I go to look fors. What I see here is that I have this segment and it's broken into two parts. That's a look for. I have this segment and it's broken into two parts. So I'm going to write some segment addition out. So I'm going to say that RS plus ST equals RT. And in this same step, I'm going to say that PS plus SQ equals PQ. All I did was take the two parts that make this segment RT and the two parts that make this segment SQ, and I put it together in an equation. The reason I can say that is because we can always use segment or angle addition. So that's segment addition. Now here comes kind of the two hard parts, and this is where it starts to feel very different than algebra. So we need to somehow put this together. You don't have to flip back. I'm gonna flip back. Oh, I can't because this is a new pocket because I've already done these notes. To here, to the notes before. So on notes number 6, we looked at addition and subtraction properties. And in our algebra proofs, it was just like, hey, I subtracted from both sides, so I'm calling that subtraction. And I did it again, so I call it subtraction division. Now, the formal definition of our addition subtraction properties is if A equals B and C equals D, then A plus C together must equal B plus D together. That was our definition. So let me go back to here. This is using exactly that definition, but it's kind of hard to see because we've never done stuff like this before. So I know that ST is equal to SQ. And I also know that RS is equal to PS. So if I know RS, leave a space, is equal to PS, then I can add the same thing to both sides of an equation and it doesn't change the fact that it's equal, okay? So what I'm going to do is add an equal amount to both sides. I'm going to put ST over here and SQ over here. All I'm doing, this is the same as the property. If A equals B and C equals B, then A plus C equals B plus C. That's our addition property. We're taking these two that are equal amounts and we're adding the same thing to both sides of this first equation. Okay, that's all we did. We added an equal amount to both
Are
sides.
you not allowed to switch? Like,
Well, you wouldn't want to because I want it to look like this.
you're really just like squeezing it in.
Just adding, yep, to both sides, this and this. Many times too, you'll be given like a fill in the blank proof, so it'll help you kind of see what you need to do. That's just the addition property. I added an equal amount to both sides. Now, here's the, like, kind of feels like a magic trick part, is how do you get to the end here? Well, there's all sorts of ways you can write proofs. You could write a whole paragraph, like an essay, as a proof too. We don't do those.
Some
Can I do that
mathematician
instead?
Okay, so notice that by adding ST and RS together, that's exactly what I have here. I have ST and RS, ST and RS. So would you agree with me that I could substitute RT in its place? Because RS plus ST, yeah, I can. And over on the other side, I have PS and SQ, which I can substitute in PQ. That is what substitution property looks like in a geometry proof, which really isn't that different than algebra class. I'm still just substituting something in. But because this is equal to RT and this is equal to PQ, we can substitute in. Guess what? We're done. That's what it wanted us to prove. Okay, that's what it wanted us to get to, is that RT is equal to PQ. So what we may want to do, I just want to go back up to substitution property, little star, and put it down to that last piece, just as an example in a geometry proof of where you see substitution being used. We're going to use it again in the next proof anyway. Yep.
So we have the given the first part, P, if you remove S from both sides,
S?
Why can't you?
No, because ST is not like S times T, it's segment ST.
Why?
yeah, no, but it's still equals F to Q.
But T doesn't equal Q.
No, but then when you have R equals T.
I know what you're saying, but you're thinking about it like algebra,
I am.
but it's geometry. So really it should be this.
This is geometry camp, come on.
It really should be this, because it's not S times T, it's segment ST. Is the same length as segment SQ.
So
Why
I
can't
just
you
like
go
sort of do it longer because I can't break it right
Just to make your life hard.
Why? Why don't you
Easy
do algebra,
answer.
algebra, geometry? Or geometry, algebra, algebra?
Okay, flip this over. So honestly, because of state testing usually, because there's geometry and state testing.
can literally.
So they want to make sure you get it before you're a junior. Okay, so we're adding another property. Okay, this one seems silly at first. You'll see why it makes sense in a minute. Reflexive property, that A equals A, that something equals itself. Okay, it seems kind of like, well, why do we even need that? I'll explain why we need it when we're doing this next group. Okay? But that's our reflexive property. Really simple property. You'll know it's a reflexive property if you have to use it. So, another proof. Statements, reasons. First thing I'm going to do, and you may want, I like to use different colors on my diagram. It might be helpful if you get some colored pens, just it's easier to see. So, my given is that AOC. So here's angle AOC. As I'm kind of color coding AOC as best I can, it's not really showing up that great. I'm noticing that AOC is broken into two parts. Maybe I'll have to use angle addition here. And like AOC is angle 1 and angle 2 together. That's what I'm noticing, that it's broken in half. So I have AOC is equal to BOD. There's BOD, and BOD is also broken into two angles. It's angle 2 and angle 3 put together. So these are equal measurements. I've marked my givens, and I need to write it down. The measure of angle AOC is equal to the measure of angle BOD given. I always have to write that given in there. Now, before I just start writing things, I've noticed, again, it's a look for, I've looked and seen that my angles are broken into two parts. So I'm probably going to start with angle addition. And I will start with angle addition. But before I do that, I want to see, what do I want to prove?
One.
That the measure of angle 1 equals the measure of angle 3. Would it make sense that 1 and 3 are equal in measurement?
Yeah.
Yeah, because all that's between them is this angle 2. So if these two angles are the same, I take angle 2 out of both of them, and this must be the same amount left behind. So I can see that, but I need to write it. So what I need to do is get rid of this angle 2 from what I have. So I know that these two angles are equal. I know that AOC is equal to 1 plus 2. You okay with that? AOC is 1 plus 2.
Wait, what? I don't understand what you said.
This angle is angle 1 and angle 2 together.
Okay, so you wrote,
Measure of angle 1 plus the measure of angle 2 equals the measure of angle AOC. That pink
oh,
angle.
got it.
And I can also write in the same step that the measure of angle 3 plus the measure of angle 2 is equal to my other angle, BOD. That's 3 plus 2. That is something I'm observing from the diagram. It is a look for, and it's angle addition. Okay. Now, if I am given this first formula, well, if AOC is equal to BOD, here's AOC, here's BOD, couldn't I just, where AOC is, substitute in 1 and 2? And where BOD is, substitute in 3 and 2?
You're literally just repeating, you're just
Just
writing
writing.
over and over again in different forms.
No, not, well, kind of. Yeah, I'm transforming this so I can get to here. I need to take this and make it look like that.
Math is confusing. I don't understand what you're
So I
saying.
can't take this and make it look like 1 and 3 with these letters in here. So I'm gonna take AOC and write it as 1 and 2 together, because that's what it is. And I'm gonna write that BOD is 3 and 2 together. So let me write that, and then you might see it. So instead of AOC, I'll have 1 plus 2 equals 3 plus 2. And all I did was substitution. You see how that's substitution?
And then you can remove that and
I don't know what you're doing.
Now it is like algebra class, Cam, right? Because I could just, but don't do it yet, because that's not going to be our next step yet. Okay, all I did was take my equation that was given to me, I know this is true, and I substituted in what AOC is, and I substituted in what BOD is.
What? Can you repeat that?
Yeah, I'm given this equation. I know AOC is this, right? 1 and 2 together. I'm just substituting in what AOC is, which is 1 and 2 together. And I know that BOD is 3 and 2 together. So I'm just putting that there instead of BOD. Because I know that that's what that angle is made up of. Now here comes the tricky piece. If you are writing this proof, yes, this is like algebra class. But if I just want to say 1 and 3 are the same, then can I just subtract angle 2 out from
Wait,
both sides?
why would you write equals like M3 plus M2? Because that's one angle, not the other one. Oh, wait, what? Oh, you just took, okay,
Okay,
I guess.
okay. So I could subtract angle 2 from both sides, right? Because they both have angle 2. So just like an algebra equation, I can subtract this and it would eliminate it on both sides. But we need to state in our proof, this is how specific proofs are, that this angle 2 and this angle 2 are the same angle 2. We know it's the same angle 2, we see the diagram. Okay, but it could have been 2 separate angles with 2 different angle 2's written in there. So before we can subtract that, we need to say this angle 2 is equal to angle 2, that the measure of angle 2 is equal to the measure of angle 2. That's that new property reflexive. Okay, where we say this is the same angle. Talking about the same thing on both sides of that equation. Like over your reflection.
Like,
It's the same. Yeah. So then I can now finish my proof because if this is the same, these are equal to each other, and I can subtract and subtract, and I'm left with 1 equal to 3. And what I did is I subtract, I'm just going to write to the side. What we did from here to here is we subtracted angle 2 from both sides. I know, it's like, today's hard because it's the first time we're doing proofs like this, so it feels horrible. But I promise it starts to get easier. But it's not, never, ever, ever, ever has a geometry class seen this on the first day and been like, that's so easy. These were the easiest notes.
I
It's
just
always
did. This was so
confusing.
easy.
Ah, there you go. There you go. Good. This is so easy.
Yeah.
Okay, it's gonna feel hard, and it's gonna feel hard when you do the homework, and it's gonna feel hard when we're doing the quiz review. It's just gonna feel hard.
I said I like the if-then statements better.
If
Yeah,
then
those
statements
are
are
the-
much clearer.
Those are so much easier and not complicated in any
It's
way.
boring, it's like if A equals C.
I still don't understand, the compound is literally the same as what you said.
The what?
Like, there was like a. there was
But
like-
it's the.
Oh, but you're
That's
flipping it.
proving that it is.
But you're flipping it.
The common.
A converse?
Yeah.
Like if today is Friday, tomorrow is then tomorrow is Saturday. If tomorrow is Saturday, then today is
The
Friday.
only part that I think is.
Restating it, but flipped around.
But isn't that not, that's not it?
I thought we were doing English.
The only.
Yeah.
It felt like English
It
class.
felt like
That's
English.
The only thing that I think confused me was the if and only if statement.
Mm-hmm. Yeah,
In
right,
that
together.
part, but other than that.
Okay, so this page, I'm gonna give you a warning, because I'm warning you. This is the hardest proof we're gonna do today. Right, it's hard. We can do it, right? I will never ask you to reproduce this particular proof, but just to kind of show you that in order for them to write these theorems, somebody had to prove them initially, okay, somehow. May not have been in a 2-column proof, may have been in an essay that they write about why this is true, but somebody had to make sure it was true. Okay, they didn't just come out of thin air. So, these are things we've already talked about. They are vocabulary words from Unit 1, midpoint and bisect. A midpoint means that I have a segment, right? So draw a segment AB. And a midpoint means that there's a point exactly in the middle. We'll call it X, where the distance from A to X is the same as from B to X, that it's exactly in the middle, it's a midpoint. Every time that you are given midpoint or bisect, I call these follow-up statements. Okay, we have to follow it with definition of midpoint or definition of bisect. So I'm going to give us an example for each of these up here. So if I am given that X is the midpoint of AB. Okay, so that in my proof, that's what I'm given. So I would write my given, that's my first step, and then my next statement would be that AX is equal to XB, or I could have gone the other way, BX, whatever. Okay? And the reason that I can say that in my reasons column is definition
Wait, can I say BX?
of midpoint. Okay, we always follow a given that something's a midpoint or bisect. With definition of midpoint or definition of bisect, always. You never want to forget to follow up those givens. So, an example of bisect. Bisect means it's an angle typically. Sometimes it's a segment and they use the word bisect. For the most part, we're looking at angles there. So A, B, C. Now, just like midpoint, bisect, cut in 2 equal parts. So if this angle was cut in 2 equal parts, we'd maybe have a ray try to draw it somewhat in the middle, call it X. That it's cutting the angles into 2 equal angles. And to make our life easier, I'll call it angle 1 and angle 2. Then I don't have to use the letters. So I labeled it 1 and 2, but they're the same because it's bisected, cut in equal parts. So if I am given that BX, that ray in the middle, bisects angle ABC. Given that something bisects an angle, a segment, whatever, I follow it up with this statement and this reason. So my statement would be that angle 1 equals angle 2. Really, I should have measure in front. The measure of angle 1 equals the measure of angle 2. The reason I say that is definition of bisect, just like definition of midpoint. It's really the same idea, just different words. So now we're going to tackle the hardest proof of the day, followed by our last and easiest proof of the day. So it's like really hard, and then we'll end on a nicer note. So here's our midpoint theorem. If M is the midpoint of AB, then AM is half of AB, and MB is half of AB. So given that theorem, I'm going to give you a given and something to prove. So our given is going to be that M is the midpoint. I tend to shorthand midpoint like that of AB, segment AB. That's our given. And I'm going to ask you to prove the first part of this theorem, that AM equals 1/2 AB. So, statements, reasons. My first statement is always my given. So M is the midpoint of AB. Given. Anytime I am given midpoint or bisect, I have to follow it up. So my follow-up to this statement is that AM equals MB, or you could call it BM, because that is the definition of midpoint. There's the follow-up statement. So given that it's the midpoint, that means that this half is the same length as this half. Okay, feel okay with that? That one's a little easier. We always follow it. That's the biggest rule. Like if you see, you write that something's a midpoint, right? That something bisects it, you follow it with what parts then are equal. Okay, so we've done our given, we followed it up with what we needed to follow up with. We have no other anything except for the diagram. And when I look at that diagram, what can I use from that diagram? That is a segment broken into 2 parts. So what else do we know?
You also know that AM plus MB equals 3.
Right. So that's again why I call it a look for. I look at my diagram and I see that I have parts of a segment making a big segment. So maybe I need to use segment addition. All I did was I said I have this segment AB and it's made up of AM and MB. Here's the magic trick moment here for this proof. AM equals MB, right? So where MB is, could I substitute in AM? Yeah. So I could write, instead of AM plus MB equals AB, I could write AM plus AM equals AB. Okay, and what I did there was substitution. I knew that MB and AM are equal to each other, so I put AM in its place. Intentionally so, because I want to be left with just AM and AB in my final equation. So now I have just AM and AB. Let's hope we can make this work. Ready for the magic? So that substitution allows me to say that 2 AMs equals AB. All I did was I said I had 1 AM plus 1 AM. Sounds like I'm talking about time. Add that together, I have 2 segment AMs. Okay, all I'm doing is combining like terms.
Actually, understand.
Good. And now it's kind of like the algebra proofs we were doing in the notes before. If this is true, then I could divide by 2 on both sides to solve for AM. And if I divided by 2 on both sides, that would be AB over 2, or 1/2 AB. We just did division. And boom, we're done. That's what it wanted us to prove. If 2 AMs equals AB, then 1 AM equals half of AB. We're not going to do the next proof because it's essentially exactly the same, just with a bisector instead of a midpoint. And they're a little bit of tricky proofs to begin with, so we're not going to do that. And we've done a lot of proofs today. So in terms of new properties, really reflexive property was the only new one. Okay, we already knew about midpoints. We already knew about segment and angle addition. We just haven't used them in a proof yet. This last property, transitive, is also a new property. Now, transitive is a little tricky because it feels like substitution. And it kind of is substitution, but it's substitution when there's a chain of events that allows us to connect them. So for example, if I had A equals B and B equals C, then if A equals B and B equals C, then what else is equal to each other? Then A equals C, good job. Okay, and with transitive property, and it may not be written this way, it may be written like as a sentence. It's like a chain, so B connects to B, and then I can connect A and C together at the end. It kind of feels like a chain is happening where I'm linking together all of these statements to say A equals C. So if A equals B and B equals C, well then A must equal C. I'm going to when I did this with the blue group, I didn't like the way I wrote my statement, so I'm going to change it up. It's going to be the fastest proof. So here are givens. I'm going to start with the first one. AB is congruent, which means equal in length. Some of our proofs use equal, some use the congruent symbol, really same idea there, same length. So AB and BC are the same length. I'm going to go out of order here and go here to BC and AB. Oops, sorry. BC is congruent to AD. Oops, given. Number 2, given. BC is congruent to AD. So that would also get a single tick mark. Okay, BC and AD. AB and BC are the same. BC and AD are the same. Now, right now, we could say then those two are the same, right? We don't, it's not asking us to, so we don't need to go there yet. My other given is that AD is the same as DE. Given. So I mark that AD and DE. So really, all of those parts are exactly the same. And we want to say that DE is congruent to AD. Well, we can do that because look at this chain. AB is congruent to BC, and BC is congruent to AD, and AD is congruent to DE. Do you see how they all can link together to say well then, AB must be congruent to DE. And that's when it's not substitution, but it's transitive property with a train. Okay, they're all connected. AB equals this, and this thing also equals that, and that thing also equals that. So then A, B, and DE must also equal each other, okay, because they're all kind of linked together. And that's the end of our proof. That's what it wanted us to prove in the end, right? Okay, how did I do on time? I was a little nervous we ran out of time. We have time.